In this session, we're going to be looking at composite volumes and surface areas. Previously, we've been looking at basic three-dimensional shapes. And so there was the cube, which if you remember, something like that. There were cuboids, which were looked very similar to that, but each side was different. You had prisms, which looked like that. Hopefully you should remember all of these. Pyramids is an easy one to remember. So something like that. Cylinders. Cones. Something like that. And obviously spheres. And my drawing looks like a circle, but it's supposed to be three-dimensional. Now, many of these shapes occur on their own. You can find them in loads of places. But they also occur in hybrid combinations, in that you get one of these connected to one of those, and all sorts of combinations. And you probably see this in stonemasonry a lot, where there's different sorts of curves, different sorts of structures. So watch out for them. You can work out the total surface area and the volume of these hybrid combinations if you know the basics of these, which hopefully from the previous videos you do. So we're going to take as our example a salt shaker. So this is what you use at the dinner table or whatever when you're cooking, and it's made up out of a cylindrical body, which is this bit here. This is where the salt goes in, and then there's sort of like half a sphere, which is this part here. And this has the holes which allow the salt to come out. And half a sphere is known as a hemisphere. So hemi is half. Okay, so keep that in mind. So one question is, how do we work out the volume of this salt shaker? Well, knowing that it's part cylinder, it's cylinder and part sphere, then we can apply what we've learned previously to this. So let's start with the volume. So the total volume of the salt shaker is the volume of the cylinder, so that's this bit, and the volume of the hemisphere, that part. So the volume of a cylinder, we know from previous videos, is pi r squared h. Now here for the salt cellar, h is 5 centimeters. So if we substitute these values into this equation, so pi times 1.5. Now where does 1.5 come from? I can't see a 1.5 here. Well, it comes from this. Do you remember me saying that examiners, they often give you certain values, and it's up to you to process that value and to get the value you actually need. So here they've given you the diameter. And really what we're after is a radius. Now knowing the radius is half the diameter, the radius is from the middle out, diameter is from one side to the other. All we have to do is to divide this by 2. And this is where the 1.5 comes from. So the radius squared multiplied by 5, which is the height or the length of this cylinder. So that's the volume of the cylinder. How about the volume of the hemisphere, which is this part here? So a volume of a sphere is 4/3 pi r cubed. And because this is a hemisphere, half of it, then if you multiply that by half, then that gives you half of this sphere. So let's go ahead and substitute the numbers. So it's half, 4 times 4 over 3 times pi. Now throughout this, use pi equals 3.14. Okay, so you can substitute that value in there, times r cubed. R we worked out previously was 1.5, so cubed. And so the total volume of this shaker, so that's the top and the bottom, is this value here, which is repeated down here, plus this value here, which is repeated here. And when you do the mathematics, substituting pi for 3.14, you get this sort of value. And because it's volume, and because it's in centimetres here, then it's centimetres cubed, cubic centimetres. So now we've worked out the volume. Let's have a look at surface area. So that includes the whole bit on the outside. Let's move this page up a little bit. So let's look at the surface area. So I'm going through this relatively quickly, and you can take your time over it, but put the video on pause and see if you can work out all of these values yourself. So let's have a look at surface area. So again, this is surface area of a cylinder and surface area of a hemisphere. Now the surface area of the cylinder is usually pi r squared plus 2 pi rh. And we've got that from a previous video. So remember that there's the base over here, and we need the surface area of the base, and then we need the surface area of the curved bit. Now normally in a cylinder, when we're working out the surface area, oops, let's do that again. No, that isn't very good either. So that's better, and that's the bit down at the bottom. Then there's this surface area and that surface area to look at. Well, this salt shaker doesn't have that top because it's open. That's where the hemisphere fits. Okay, so we're only looking at one part of it. So when we substitute all the values over here, we get pi times 1.5, the radius halved, so that's that part, plus this part here, 2 pi 1 times 1.5 times 5. Now, that gives you the surface area of the cylindrical part. What is the surface area of the hemisphere? So the curved surface area of the hemisphere equals half, because we're only looking at half the hemisphere, multiplied by 4 pi r squared. And then substituting all the numbers for these, and again use 3.14 for pi, multiplied by that. And so the whole surface area is of this cylinder plus that hemisphere. And when you do that calculation, you should get something like this. Now note that surface area is not cubed but squared. So this is what you should end up. So give that a go. Also, why not practice a little bit and change these values to whatever you want. Let's change it a little bit. Let's change that to 4. Let's change this to 2 and see what effect that has. Work through all of this. See what, compare the values with the ones you put in with these. See how much they change by.